Thank you, Girish sir. That was truly very different from anything I had seen so far. And I'm sure he'll be happy to share more on that during the interaction that we have. Now, our next speaker for today is, of course, Gilbert Raynard. I'll just switch on his. Sagar, would you like to give an introduction?
Hello. Sure. Yeah. Thank you, Girish sir. So as I said, after graduating, Girish sir was my first director when I started as an employee. And Gilbert Raynard was my last director when I was done with the being employee before starting SSC. So Mr. Gilbert Raynard have spent 47 years in the industry, most of it as a director. They call it principal over there. He has seen the time where Canada did not have any building code, and then Canada have building code, and now it has been developed so far. He has he has commitment to optimal design solutions. I have worked under him, so I know how much he care about that. With over 4 decades at RJC Engineers, by the way, RJC is Reed Jones Christopherson. They are the biggest structural engineers in Canada in building design. He has designed about 140 high-rise buildings across USA, Canada, and India, contributed globally in Australia, Hong Kong, Germany, and Japan. His portfolio includes seismic upgrades of historic buildings, school designs, etc. A University of British Columbia graduate, he has begun his career at RJC and spent 44 years with them, including 34 years as a principal, equivalent to director here. Currently, he's serving as a principal emeritus at RJC and external advisors to us. He actively participates into provincial, national, and international professional associations, underscoring his leadership in the field. He is a professional engineer at Engineers and Geoscientists of British Columbia, Association of Professional Engineers and Geoscientists of Alberta, Manitoba, and structural engineer at California, registered structural engineer at California, Washington, Arizona, Nevada, Utah, Idaho, Colorado, Hawaii, and Texas. He is also on the Council of Tall Building and Urban Habitat, CTBUH. I'm glad to invite Mr. Gilbert Raynard for his views on the topic. Thank you.
Thank you, Sagar. I'm going to talk about things related to high-rises with, of course, a Vancouver perspective, because that's where I've done most of my work. All the buildings you see in these slides were done by my company, except 2, and I'll tell you what those are. We also did the convention center here in Vancouver, which you probably have seen pictures of. So I'm just going to go back one. So these are the topics I'll cover. Urban density, building height, complexity of buildings, a short talk on the phasing of construction, and a short talk on modern high-rise, the way we do them in Vancouver. This is what Vancouver looked like in the mid-1950s when my parents immigrated to Canada. There was only a few high-rise buildings, and they were all designed by people in Toronto and Montreal. There was no local engineers. And this is Vancouver now, 70 years later, with all of those wood frame homes changed to high-rise buildings. Lots of resistance by people of this change, but the change is inevitable. It's like a roller coaster, and it needs to be managed. And on this picture on the left, of all those buildings, my company has done about 1/3 of them, about 33%. This is not an RJC building, but I use it to illustrate, this is the Burj Khalifa, the tallest building in the world. Extremely high buildings you will not see in North America, because in North America, buildings all need to have a business case. The Burj Khalifa only had a business case because the owner owned hundreds of acres of land around it, and so even though they lost money on this building itself, it increased the value of all their own property. In a city like Vancouver, and I think Pune, too, if you build a building of this height on a small city lot, you are going to be donating millions of dollars to your neighbors. And this is why our buildings in Vancouver tend to be at a sort of an optimum financial logic, which is about 30 to 40 stories. Buildings also cannot be too small. So this is a building that has a typical floor of only 1,200 square feet, which is really too small to build a building. But the owner was committed to doing this thing and paid for the foundation with his own money, and then when he was relying on the pre-sales, they didn't come through. So this building is currently sitting at grade for 2 or 3 years with reinforcing steel sticking out that we've protected now, because the business case for these small buildings just does not exist. The building on the right is not our building, but we did the peer review, and the one on the left is our building. And you know, in these high-rise buildings like Burj Khalifa, the top third of the building is not really usable because of motion, and it takes so long to get there. And also those buildings become smaller at the top for wind reasons and structural reasons. So the best real estate, the best views, are not actually being used to sell real estate. And on the Burj Khalifa, on the 4th floor, they can't get more rent than they can in a 30-story building on the 4th floor. So the rationale for these tall buildings, it sort of falls apart because of these reasons. And as I was mentioning, the real estate at the top is more valuable than the real estate at the bottom. And so this is how this was solved for an office building on the left. The biggest floors are at the top, and it created a beautiful wide sidewalk at the bottom. And on the left, that's a residential tower. Again, the best real estate, most of the real estate is very high up, so they were able to earn more money. However, they paid a very big price for the structure because this structure leans one way. So 24 hours a day, 7 days a week, there's a dead load desire to fall over. Whereas the other building is symmetrical, so it's very happy just sitting. These 3 buildings, very tall buildings that our company did in Toronto, where we tend to build a bit bigger because there's no earthquake in Toronto. The ones on the left and the right did get built. The one in the middle, it's called The One, and I think you have a building in Pune called The One. I don't know who stole the idea from who. That building will be the tallest building in Canada. It's 340 meters, 1,000 feet. That was the magic number. But what happened was it was simply too big for the city, for the developer. So they've constructed it about halfway up, and cost overruns, and also the market didn't materialize for such a big building. And so now the building has been sold and they're going to start again, but it was almost too big to make a business case. It was a bit of an ego project. Another reason to build tall buildings, one of the reasons all the really tall buildings are built in the Middle East and China is because these are top-down governed economies where the leaders will say, of a city in China, for instance, will say, we're going to build a dramatic landmark, and then this will benefit our whole city. That's not how things work in North America. Everything is private sector for these kinds of high-rises. Also going down, in Vancouver, the city planners do not want to see the buildings, they want to see the buildings as small as possible to maintain views and shadow and sunlight, so the parking is always underground. However, the cost of building underground is enormous, and what every developer needs to do and doesn't always do is get very good geotechnical information before they purchase a piece of land or make a commitment on a project. So for instance, this was at the time the deepest parking lot in Vancouver, 6 stories. We're now doing 8 stories, and as long as it's dry, it's okay. But what's happening now is that we are getting it, as we move out of the city into other areas, we're moving into areas where the water table is quite high. But the city planners still want the parking underground, and it's simply not feasible. The cost of dewatering during construction, the cost of waterproofing, and the buoyancy that having water pushing your building up cause delays and costs that make the projects unfeasible. And often the owners don't know this when they start, so then there's a big disappointment at the costs. So in areas where the water table is high, believe it or not, Las Vegas, which is a desert, has a water table only 3 meters below the ground. So the building on the right, we put the parking above ground, and we clad it nicely with an architectural finish. And the building on the left is in Winnipeg, also water table quite close to the surface. The architect put a beautiful base on the building to make the parking not so ugly. But what we also do in what we did on this project in a town called Kelowna near Vancouver is that we put again, we're near a lake, can't go below ground because of water. We built the parking and then we surrounded it with residential units so that no one really knows there's parking in there. It just looks like a residential tower right to the base. This all costs money. It's hard to mix and match these uses, but that was a solution. Sagar worked on this job. This is the tallest building I've ever done. I don't get to do really big buildings because, as I was saying, there's no business case. It's 170 meters. And you can see here the limitations in a high earthquake zone of tall buildings. This building is 51 floors. And you can see the core, the center core, the concrete. This is a floor plan. Now we have 4 elevators. And we have very thick and long walls. And so the floor efficiency, developers want in Vancouver to have 85% floor efficiency. That's saleable area divided by total area of a floor. If they can't get 85%, they start to give the architects hell. And we're just not getting 85% on these buildings because of the structural costs. The columns are also bigger. So that's another limit on size, on height. So high-rise buildings traditionally are used for 3 types of buildings. On the left, office buildings, of course. In the middle, a job we did in Texas, residential. On the right, our tower in New York, hotel. Office, residential, hotel. Those are the uses. And residential can be strata or rental. But we are also now in Vancouver, due to density constraints, starting to do high-rise hospitals. That's the biggest hospital in British Columbia. And the building in the middle there, I don't want to hit the wrong button, so I'm just going to point here. This one, this is a university campus. So universities are also amenable to high-rise construction. It isn't often done, but this is kind of the future. And if you go to Europe, you see that universities are always in multi-story buildings. Okay, complexity. On the left there, we have a project that has market residential, market residential owned by the owners, the individual owners of each unit. We have affordable housing that the city forces us to put in, owned by the city. We have daycare center, forced by the city to put in, owned by the city. We have office, owned by the developer, renting it out. We have retail, owned by the developer, renting it out. We have an enormous truck bay to service the grocery stores, and then we have parking. It's a triangular site, and it's a slope site. It's almost too complicated. The owner didn't do well. Developers always make money, but they didn't make a lot on this one. And the question I have is, with this fragmented ownership, how are decisions going to be made on this building? The big decision, I'll be gone by then, but in 100 years or 150 years when this building is demolished, how will you, with such a fragmented ownership, dissolve this building so that it can be rebuilt? I don't think anybody's ever figured that out yet. This is a problem we've kicked down the road. Actually, I never finished that slide. On the right, it's a building, it's residential right down to the ground. It's an oval shape. The columns are at radial lines, but there's a parking below that is orthogonal. But every column, there are no transfer columns except at the ground floor. So at the ground floor, a lot of money was spent, 2 months to build it, and then the building went up 1 week per floor, no transfers. It's a very complex building, but it's not complicated. It's a beautiful building, not complicated. As I showed you in that earlier slide, Vancouver has been transformed from a city of wooden houses when my parents came to a city of high-rise. And we keep pushing out into the beautiful neighborhoods of single-family homes, destroying neighborhoods. I mean, my whole life has been destroying beautiful neighborhoods. That's how I made my money. And there's a lot of resistance. And the resistance gets stronger. Developers have a lot of trouble getting permission for these kinds of projects. And I'm sure you know this expression, NIMBY, not in my backyard. Everybody loves towers, but they don't want them in their neighborhood. So there's a lot of, the pipeline for building is always being clogged by the council, by the building departments as they try to satisfy the voters. On the other hand, if we just let ourselves build like crazy, well, for one thing, there'll be chaos. But we can do it. We have the construction and the engineers and the financing to build much faster. But the government is very reluctant to allow prices to fall because the investment people have in their homes is their biggest investment. So there is almost a suicidal move to constantly higher prices so that the only people who can afford even this condos, like none of my employees can afford to live in this condo unless they have parents who help them. And that's really what's propping up our market, is the transfer of wealth from the baby boomers. But the prices never go down. So in these high-rise buildings, how do we replicate the lifestyle and the quality of life that we had as children living in single-family homes? Because you can live in a high-rise building and you'll be lying in bed and a meter away is someone else in their bed. You do not know that person. You might not know what they look like. But if you're a farmer and you have a neighbor 1 kilometer away, you will be friends with that person. That is a very strange thing about high-rise buildings. You don't get to know your neighbors. So there are attempts to create a feeling of community in these buildings, and it's very difficult to do. So on the left, those 3 towers we did. The tower on the left the owner took the top 2 floors and created a huge amenity for all the renters in the building to use, with pool tables and large TV screens and barbecues and party areas, as in a way to try to get people out of their units and at least meet the people in the building. You would not meet the people on the street, but you would meet the people in the building. The problem they found was that everybody was stealing the lamps and the furniture and the cushions and stuff, so that became a problem. And on the right, it's the same building, 2 pictures of the same building. We created these sky gardens, again, outdoor areas where people could meet. Again, the problem is that you only meet the people in your building, but at least you have a place to go where you can, on a neutral ground in the building, meet your neighbors. More successful, actually, for living are these medium-sized buildings like this. This one was actually designed by Sagar when he worked for me. Smaller scale, also, of course, much easier for the developer to build quickly, easier to sell out, so forth. A little bit about structure. So if you've worked with a structural engineer, you know that we don't like transfer beams or transfer slabs, but sometimes we need them. And if there's a compelling reason to spend all that money on a transfer structure, then that's justifiable. But I have seen in my career hundreds of millions of dollars wasted on structure that was actually never really achieved much. Because when forces go down a column, it's very cheap. Costs nothing, costs nothing. The minute you go like this, it costs a lot of money. It costs money in time, material, and headroom. And the 2 buildings on the left are our typical model. That one is at there's retail at ground floor, so we take the parking grid up through the retail. Then we put a transfer beam, and then we have another set of columns for the residential. And on the right, or the middle one, that's where the residential goes all the way to the ground. Then we put our transfer at the ground floor. And you can see, just to get an idea of the cost and complexity of transfer beams, look at the human body, which is the evolution of millions of years. So you could say it's the most perfectly refined structure. And look how much of the body, how much of the energy and weight and effort of the body goes into this transfer structure. And yet, you can also justify it because that transfer structure in the body, the hips, this huge hip bone, well, there's a compelling case for it because we need 2 legs to move, but our upper body is a single column. So the body has decided over millions of years that this is a logical thing to do. So if it's logical, do it, but don't do it if it's not logical. Talk briefly about phasing of construction. So I've been involved in a number of projects where the design was such that the original dream was to do many towers on one platform, but then the reality of pre-sales was that they could only do one tower. But the design was such that the parking entrances, the emergency generators, the connections to the street, for each tower depended on the entire base being built. So now we're looking at this tower that we've just finished designing. The owner only has enough sales to do one tower. But the design means the way it's designed, he has to build the entire base. So he has to spend an enormous amount of money and have only the income from the one tower. So we're recommending always, if you have a large multi-story building and you're not sure that you're going to sell it all, treat each tower as a separate project with its own mechanical, electrical, entrances, sewer connections. Build that as if you were building in the city on a small lot. And then 10 years later, when it's ready for the next phase, then you build another project. Chances are you'll build something else because the market changes. And so phasing. We've also done vertical phasing. So the building on the left is one of the biggest office buildings in Vancouver. There was so much square feet that the market couldn't absorb it at once. So we built half the way up, capped it. People moved in, worked for 10 years, and then we continued to finish the top while the people still worked below. And on the right, you see we tried to preserve a historical building. It's the old stock exchange, which now, of course, is all done on computers, so we don't need a stock exchange. And the new building sits over it, and we put columns down through the historical stock exchange to support the new building, and the stock exchange became a hotel. And this just died. Now, why is it doing that? Oh, maybe there was just a blank in there. Okay. So this is my building in Chandigarh, where an owner who was based in Mohali, Chandigarh, found out about the way we were doing buildings in Canada, and he thought maybe this would work in India. So what the system here is what we call the flat plate. It's a 200 millimeter slab. In the slab is full of electrical, telecom, even mechanical ducts, very long, flat mechanical ducts to vent the bathrooms and kitchens. And the floor is completely flat, and it's a fire separation, it's an acoustic separation, it's a ceiling, we just paint it, and it is the floor. So this is the thinnest possible way to get all those things happening. But what the reality of India, what we learned was that whereas in Canada or in the United States, our plumbing in the bathrooms goes through the slab, and then all the pipes and the elbows are underneath. They're actually in the ceiling of your neighbor down below. They said this was unacceptable in India, so we had to break this beautiful slabs with a 16-inch recess under every bathroom. Almost finished. So this flat plate system, we're building them one floor per week. This is up to 10,000 square foot floors. Somebody say 15 minutes? Oh. So we're building, the slab is being poured at the top, 3 levels of reshoring, and then you're already seeing the windows coming in. So 1 week per floor is now the expectation of the developers, and so the engineers and contractors have to do their designs and their construction to meet that schedule. This is another tower, and this is just a recent tower. I just brought it because Sagar did most of the work on this, and it just shows one of our towers. It just topped off. If you look on Instagram, my RJC Instagram, we just posted it, and it shows a sort of a typical 40-story tower, and there's some beautiful pictures of our analysis. This is my other tower in Chandigarh. It was the first one I did, actually, and on this one, the way you build in India is that all your partitions are made of brick. And so we did that, but we found that the building was so much heavier than what we build in North America. So on the second tower, which was that earlier picture, the owner agreed that all interior partitions within the suite, would be done out of a lightweight material. But the partitions between suites still remained as brick. And I always show this picture of me working because, as you know, probably all of you know somebody who's immigrated to Canada. Canada, Vancouver in particular, is full of immigrants from India, many of whom end up in our industry, architecture, development, building, engineering. And we've inherited from the British, both of our countries, a way of doing our business. Everybody's roles are the same. So when I go to Chandigarh and I go to these meetings, I forget I'm in India because everybody's speaking English. Many people are Indian, just like home. And the mechanical and electrical and architect, they're all saying the same things, same problems, same discussions. It's kind of funny. Thank you.
Thank you so much, Gilbert. That was really interesting. And we got to see all these buildings, which I would never have seen and known so much about it. So really delightful presentation. Well, friends, it's time for our third keynote speech. We are slightly behind schedule. I apologize for that. But I think we have made it all the way here. So I request all of you to bear with us for some time. And here's the stage in the presentation where I call on our third keynote speaker. Give me a minute. I would like to introduce Shri Devendra Potphode. I'm not going to give a lengthy introduction of his because it's all there on the internet. I will like to say something about what I perceived about him when I first heard him speaking at a beautiful SEMCON conference where I was invited by friends who are sitting here. Dhairashil and Prakash Medhekar was also there. When I heard him speaking, he came in the room and everybody started looking at this person. He came, immediately got to the topic, and some of the facts and figures and incidents and anecdotes that he narrated during that very crisp talk were chilling. They were chilling, they were disturbing, they were thrown at the face of the audience by this gentleman who is completely devoted to his work. Ladies and gentlemen, I request our dear fire officer of the entire Pune region, Shri Devendra Potphode, to please come on stage and start his talk. Just a trivia, you won't find many photos of his on the net. There is one particular photo where he's also in a firefighter's dress and he's standing with his men. I actually was tempted to put that photo here, but well, protocol took over and I was convinced by myself to put this photo. Devendra sir, over to you.
My pleasure. Thank you very much for nice words. Good evening, friends. It's really, I'm really very happy to be associated with Sagar and Shekhar. They have come up with the idea and they thought we should think something about the Pune city after 25 years. When respected Girish sir and Mr. Gilbert has given the presentation, I think they have almost done what we expect. The only thing is that being a chief of the fire department for the entire Pune region, I thought I should also share some of my expectations from you all known faces, most of the developers, architects, structural engineers, and so many good friends. See, before we go for 2050, I would like to give some thing about 2025. What are the hot issues we are facing as far as concerned about the high-rise structures, high-rise buildings are concerned? We have to think 2050 after 25 years. But what are the problems we are facing right now? So many people, those who are meeting me day by day, there are 2-3 major issues about the recent notification issued by the government about the intermediate water tanks, then fire tower, the duct sizes, the glass facade, ACP panels. These are very crucial elements. Then also the basement parkings. Nowadays we are coming with a robotic parking. As far as concern about the development is there, we are looking always to the European nations. They are doing, why not we? But are we really capable enough to handle these kind of challenges what we are facing today? If you just, most of the people, those must have visited our pet areas. We are showing RP road, DP road, and we are expecting ki, sir, on the basis of this RP road or DP road, please allow us to go ahead, higher. Are we really thinking ki after constructing these buildings, these RP road or DP roads or any proposed roads are going to come in existence? Really, do you think? तुम्ही लक्ष्मी रोडला जाऊन बघा, तुम्ही कुठल्याही सदाशिव पेठमध्ये जाऊन एरियामध्ये बघा, तिथे आज जुने, सॉरी इफ आय स्पीक इन मराठी चालेल ना, मोस्ट ऑफ पीपल मे अंडरस्टँड. तुम्हाला जर सदाशिव पेठमध्ये गेलात तर तिथे आज 9 मीटरचा 12 मीटरचा रस्ता दिसतो, पण त्याच्यावरती एन्क्रोचमेंट झालेलं आहे आणि ते एन्क्रोचमेंट वर्षानुवर्ष झालेलं आहे. आणि या एन्क्रोचमेंटच्या रस्त्यावरती जेव्हा प्रपोजल्स येतात की साहेब आम्हाला 45 मीटरची बिल्डिंग करायची, रिडेव्हलपमेंटची 50 मीटरची करायची, 100 मीटरची करायची. सी सरप्राइजिंगली ॲज ऑफ नाव वी ऑलरेडी रीच 150 मीटर्स आपण आता ऑलरेडी चालू झालेत आपल्याकडे. देर आर नंबर ऑफ प्रपोजल्स आर इन लाईन. सो नेक्स्ट 25 years वी मे रीच अप टू 100, 250 or 300 maybe. 300 meters. So people normally ask me, सर ते बरोबर आहे आपण ना 150 मीटरला चाललो आहे, पण आपल्याकडे तेवढं लॅडर आहे का फायर फायटिंगची? किंवा दॅट मे बी बिकॉज ऑफ कन्सर्न, बिकॉज आय एम ऑल्सो अ पार्ट ऑफ द सिटी. टुडे आय एम ऑल्सो गोइंग टू स्टे इन एनी ऑफ द बिल्डिंग. सो व्हॉट इज द श्युअरिटी ऑफ माय सेफ्टी? So here, let me tell you one thing. No, in the world, no firefighting is assured from the external side. Whatever the firefighting you have to do, whatever the safety you have to ensure, that has to be inbuilt. You go to America, you go to any of the European nation countries, or even countries like Japan, they are using 50 meters ladder. The European companies are selling the ladders to us of 92 meters. But friends, if you really have a courage to sit in that ladder, after 30 meters, 40 meters ना, ते म्हणतात नाही बस 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 वरती नको. This is the real scenario, because turbulence and all that, it's not easy to, and on that particular aspects, if you are expecting to have a rescue work or firefighting work, it's just only imagination. The film heroes can do that. So we have to ensure about the internal safety arrangement. When we are talking about the basements, robotic basements, we are getting a lot of proposals. गिरीश सर, तुम्हाला कदाचित आश्चर्य वाटेल, आमच्याकडे 9 बेसमेंटला प्रपोजल येतात. 9 basements. आणि आपण म्हटलं की पॉसिबल नाही आहे की ते म्हणतात नो सर ॲटलीस्ट 7 तरी द्या ना. रोबोटिक पार्किंग्स, नॉर्मल बेसमेंट, पुन्हा काहीतरी एखादा कमर्शियल कॉम्प्लेक्स, पुन्हा पार्किंग. काही म्हणजे कुठलंच त्याला काही ताळतंत्र नाही. See, when you are talking about a robotic parking, the major constraint is if something goes wrong in any of the vehicle, how we are going to evacuate other vehicles. Because for the ramp purpose, at least we can say, Baba, my vehicles can move out from the ramp. Single building asil, people can enter, or ramp asil, anyone can go for the firefighting purpose. When you are not sure, the vehicles are not accessible. एखाद्या समजा 6व्या बेसमेंटला खाली जर रोबोटिक पार्किंगमधल्या EV व्हेकलला आग लागली, प्रत्येक व्हेकलच्या खाली तुमचं फ्युएल टँक आहे, पेट्रोल, डिझेल, गॅस सगळं मिक्स आहे, इलेक्ट्रिकल व्हेकल्स आहेत, टायर आहेत, अपहोल्स्ट्री आहे. हाऊ मच CFD analysis will do? किती स्मोक जनरेशन होणार आहे, हाऊ मच विल बी द स्मोक जनरेशन, हाऊ द इव्हॅक्युएशन विल देअर, हाऊ मच विल बी द हीट जनरेशन, आणि त्याच्यावरती आम्ही अख्खं बिल्डिंग उभी करतोय आमची. सो वी आर ॲब्सोल्युटली सिटिंग ऑन द बॉम्ब. आणि देअर वी हॅव टू रिअली थिंक की अबाउट एक्झॅक्टली हाऊ वी हॅव टू ॲड्रेस दिस इश्यूज. वेन वी आर टॉकिंग अबाउट, आता आम्ही सुरुवातीला ज्यावेळेस फायर टॉवरचा कन्सेप्ट चालू केला, मोस्ट ऑफ द पीपल कम टू मी, सर ते मुंबईमध्ये पण नाही होत, तुम्हीच कशाला इन्सिस्ट करता. सी, ट्राय टू अंडरस्टँड द आयडिया बिहाइंड इट. When we are going 20, 22 meters, 25 floors, 30 floors, 40 floors, how the firefighting is expected to do? Are we expecting the fireman to climb 20 floors and then he should do the firefighting? Or the people, those who are supposed to get evacuated themselves, 20 माळे 25 माळे खाली उतरून माणूस येणार आहे का? पॉसिबल नाही आहे. सो दिस पर्टिक्युलर कन्सेप्ट हॅज इंट्रोड्यूस इन द नॅशनल बिल्डिंग कोड, इट इज कॉल्ड अ फायर टॉवर, which will have a staircase, lift lobby, pressurization, everything. So that in case of emergency, you can use the lift also to get yourself evacuated, or the people, those who are supposed to respond to emergencies, can enter in the lift and reach to that particular destination. पण आज आपल्याकडे काय होतंय की जेव्हा प्रपोजल्स माझ्याकडे येतात, मोस्ट ऑफ द पीपल ना, सर ते फायर टॉवर नाही दिलं तर चालणार नाही का? मी त्याला म्हटलं की समजा आपण ज्या बिल्डिंगमध्ये राहणार आहे असा विचार करा आणि आग लागली. कधी कधी असं होतं की इट्स नॉट गुड टू से की आग लागली, पण विचार करा, इमॅजिन इफ दिस इज द सिच्युएशन, व्हॉट आय विल एक्सपेक्ट. मग फायर डक्ट प्रोव्हिजन द्यायचे म्हणून कुठेतरी एक डक्ट दाखवतात, सांगतात की सर दिस कॅन विल इट बी पॉसिबल. सर एक छोटासा डक्ट आहे. वाय दॅट डक्ट, फायर डक्ट इज रिक्वायर्ड? यू शुड have your all hydrant lines, sprinkler lines, then your hose reel drums, it has to be moved properly. My sincere appeal to all of you, you all are learned, you all are having that knowledge. Please, whenever you are designing, either you are a developer or you are an architect, please ensure that whatever the safety requirements are there has to be fulfilled to have a peaceful sleep. If you want to compromise, don't compromise on these particular safety aspects. Don't try to put your electrical ducts near the staircase. This is my own experience, I'm telling you. Electrical ducts carrying all kind of electrical wires. Insulations, suppose there is a electrical short circuit, the insulation burns and the entire dense smoke accumulated near the staircases. It's very difficult to access the staircase. These are the practical experiences. Few days back, I got a very different experience. Glass facade. There were 2 consecutive holidays, and a gentleman who was sitting very close to that glass facade table, he put all his papers on the table and he went out. The quality of glass facade is also very specified. So because of the sun rays, आपल्याकडे शाळेत लहानपणी आपण ते काचेची बॉटल घेऊन ते पेटवायचो कागद. You must be aware. The same scenario happened. Cables are okay, cables are intact, and still there was a fire. So when we have analyzed the problem, and we could able to see from the CCTV, it was surprising to see that because of the sun rays pass through that facade, the paper has burned and it has started the fire. So when we are looking at the European countries about the glass facade, everything, their requirement is that they have shortage of sun heat. We are just following blindly. I am not saying we should not. We should do that. But when we are doing that, we should follow the standards. Standards are there already mentioned. So don't try to do any kind of a compromise there. Aluminum ACP sheets. ACP sheets are most vulnerable as far as concerned about the fire is concerned. It's very inflammable. आपल्याकडे ती स्टाईल झालेली आहे की मस्त ग्लास ACP लावा. ACP लावण्याबद्दल माझा कधीच हे नाही. But try to adhere to the standards. Don't try to make it some shortcuts. आणि आज there is so much inventory available in the market. Still the new proposals are coming. So don't worry about the market. Market is there. If you give a good kind of a product, there's always sale. And there's a witness of some good big projects, those are coming in Pune. They are equally, parallelly competing with the Mumbai. May not be as far as concerned the cost is concerned, but all kind of facilities, all kind of infrastructures. Rather, there are certain good projects. They are far better than the Mumbai's, because we are still having that privilege to have balconies and other areas, which is in Mumbai it's really lagging. So my submission to all of you, when we are talking about the intermediate water tanks, why this intermediate water tank is introduced? Please try to understand. When we are going up, the pump is having some kind of limitations for throwing the water. And when we are saying high rise, low rise, higher level, lower level rises, up to 15th floor I will have low rise, then up to 16th above I may have high. It looks good. There are certain pumps are also available which is called multi-stage, multi-outlet pumps. But there are certain incidences happened where the fire started on 15th floor and it turns to on 16th floor. So I have a riser, lower riser was, my final was 15th and higher riser starts from 16th. So I have to use both the risers. And when I'm supposed to use that both the risers, the pressure drastically down. So though NBC has specified the intermediate tank after 150 meter, when this PIL was filed in the High Court has given certain guidelines, and these guidelines are now mandatory for all of us. So 90 meters, above 90 meters, if it is there, you have to follow intermediate tanks. Now the real challenge to the structural engineers, because as Mr. Gilbert said, you have to see the turbulence, because your 1 lakh liter water tank is on one side. So how to maintain that load? Because if I am going above 2 water tanks or 3 water tanks, it is possible, it is already, we must have seen so many buildings in Europe, they are also following this same practice. This is not new to us. But when we have to implement first time, it's a real challenge. When we are saying we are in the seismic zone 3, comparatively very safe. But if we have to think 250 meters into 2050, we have to start it from right now. We have to think it from right now. आज आम्हाला ती सवय लागली, when we have started 2060 मध्ये, जेव्हा 2016 मध्ये आम्ही जेव्हा चालू केलं फायर टॉवर, Raynard said, we are the first in the country, we have insisted for fire tower, for a building about 24 meters. Very early. त्यावेळेस लोक असं म्हणत की अरे ते फायर टॉवर असं कसं काय होणार. देन ती सुरुवात झाली, लोकांना ॲक्सेप्ट करायला सुरू केलं. आज लोकांना ती सवय झाली की नाही ठीक आहे फायर टॉवर करायचंच आहे. तो फायर टॉवरची गरज काय आहे, त्याच्यासोबतच मला बेसमेंटसाठी काय रिक्वायरमेंट आहेत, मला डक्ट साइजेस काय असायला हव्यात, आणि सगळ्यात महत्त्वाची गोष्ट म्हणजे की इथल्या प्रत्येकाला मी सांगतो की इफ यू रिअली वॉन्ट टू कन्स्ट्रक्ट अ सेफ बिल्डिंग, तुम्ही सगळ्यांनी स्ट्रक्चर्सवरती सांगितलं, तुम्ही बाकीच्या सगळ्या गोष्टी सांगितल्यात, पण ऑल्सो थिंक फ्रॉम द फायर सेफ्टी पॉईंट ऑफ व्ह्यू. डक्ट इनव्हेरेबली सील व्हायलाच पाहिजेत. तुम्ही कुठल्याही बिल्डिंगची फायर बघा, इट ऑलवेज गो अपवर्ड साईड. द ओनली रिझन, द ओनली पाथ इज थ्रू द डक्ट्स. सो वी हॅव टू एन्श्युअर दॅट आपले डक्ट्स जे आहेत ते अतिशय चांगल्या पद्धतीने सील असावेत. वेन वी आर टॉकिंग अबाउट द हाय राईज बिल्डिंग्स, just ensure that what will be the marginal space. Friends, UDCPR says ki 6 meters, 7.5 meters is okay. When we are pitching our ladders, त्याचे जे लॅडरचे जे जॅक बाहेर येतात, ते जॅक बाहेर आल्यावरती जेव्हा गाडीची मुवमेंट अँड रोटेशन जेव्हा चालू होतं ना, वी आर अनेबल टू यूज द व्हेकल. So, if we are having some limitations in such scenarios, we have to give more thrust on inbuilt safety. आणि नुसतं इनबिल्ट सेफ्टीच्या वरती महत्त्वाचं नाही आहे. आफ्टर दॅट म्हणजे तुमचं ओसी मिळालं, माझी जबाबदारी संपली. खरी जबाबदारी तेव्हा नंतर चालू होते. कारण आता जसं इंटरमिडिएट वॉटर टँक झालं की त्याचे पंप आले, त्याचं मेंटेनन्स आलं, त्याचं येणाऱ्या सगळ्या ज्या काही अलाइड सर्व्हिसेस वी हॅव टू सी एव्हरीथिंग, वी हॅव टू बी व्हेरी केअरफुल. मेंटेनन्स इज व्हेरी क्रुशियल पार्ट. आणि लोकांना ती सवय लागायला हवी, म्हणून फ्रॉम एप्रिल ऑनवर्ड्स वी आर इश्युइंग अ व्हेरी बिग ड्राईव्ह फॉर ऑल द ओसी जेवढ्या बिल्डिंगच्या झालेल्या आहेत आणि ज्या हँडओव्हर झालेल्या बिल्डिंग्स आहेत, त्या सगळ्या बिल्डिंग्सला आम्ही व्हिजिट करून ज्याच्या सिस्टीम्स चालू नाहीत त्याला आम्ही नोटीस इश्यू करणार आहे. कारण नाऊ दिस इज हाय टाईम टू अंडरस्टँड, बिकॉज अनलेस अँड अंटिल तुम्हाला लोकांनी कितपत सांगावं की तुम्ही करा. People should, everyone should understand that this is for my own safety. I am staying here, I am working here, so I have to see. When we are thinking about 2050, we also have to see not only from the residential point of view. We have to think about the hospital buildings. We have to think about the education buildings, where my children's, where my grandchildren's are going to learn. What about their safety? पण एवढ्या मोठ्या उंच माळ्याचे आज 45 मीटरचा लोक सांगतात नाही नाही सर आम्हाला ते एज्युकेशन बिल्डिंगला आता मान्यता मिळाली आहे 45ची चालू करा. शाळा कितीची मुलं आहेत? 5वीची मुलं. सो वी हॅव टू ऑल्सो, वी आर जस्ट not a developer, we are not just an architect, we are not just only the structure. Structuralचा तर खरा पार्ट खऱ्या अर्थाने आता चालू होणार आहे. Structural engineers are the most key people, key persons in near future. You have to address all kind of parameters. एवढं उंच बिल्डिंगला जेव्हा जाणार आहे तेव्हा. And while addressing all such issues, we have to ensure the inbuilt system. We also have to think about our road network. Sometimes we get a call, fire call. This is 2025. We have to think about 2050. The aerial distance or the road distance may be hardly 2 or 3 kilometers. My vehicles require to reach the destination maybe 15-20 minutes. प्रत्येकाला असं वाटतं की अरे आपण फायर ब्रिगेडच्या गाडीला जागा देऊ, पण गाडीला जागा देणार कुठून? सगळं बंपर टू बंपर ट्रॅफिक आहे. सो वेन वी आर थिंकिंग टू गो, वी ऑल्सो हॅव टू थिंक द पब्लिक इन्फ्रास्ट्रक्चर. पब्लिक इन्फ्रास्ट्रक्चर इज ऑल्सो इक्वली इम्पॉर्टंट. पब्लिक इन्फ्रास्ट्रक्चरच्या वेळेस मला रोड कंडिशन्स, इलेक्ट्रिकल सप्लाय, माझ्याकडे सगळ्या सिस्टीम्स आहेत. पीपल आर ऑलवेज कमिंग टू मी, सध्या डिझेल पंपाच्या ऐवजी आम्हाला इलेक्ट्रिकल पंप चालेल का? मी म्हटलं बोंबला, जर समजा दोन्ही लाईट गेल्या मग काय करायचं? म्हणजे ते डिझेल पंपाला जागा खूप लागते. सो वी हॅव टू थिंक दीज आर सम प्रॉब्लेम्स विच वी नीड टू ॲड्रेस, बिकॉज एव्हरीवन वॉन्ट्स टू सी एक्झॅक्टली 20 years before, 2006, Pune has come up with the notification, government has issued a notification for the buildings of 100 meter height. 2006 ला notification आलं होतं. When I was a CFO, Pune Municipal Corporation, त्यावेळेस नोटिफिकेशन होतं. बरोबर एक्झॅक्टली ऑलमोस्ट 20 वर्ष झाले. 20 वर्षापूर्वी आपण 100 मीटरची बिल्डिंग हे स्वप्न म्हणून बघत होतो, त्या बिल्डिंग झाल्या. आज 150 मीटर्स आले. मगाशी रानडे साहेब म्हणाले की आपली 70 lakhs पॉप्युलेशन आहे, वी मे रीच अप टू 1 crore. सर आम्ही 1.25 कोटीच्या पर्यंत जाणार आहोत. आत्ताच आमचा नियर बाय सराउंडेड एरिया जो आहे, पुणे आणि अग्लोमरेटचा बाकीचा जो एरिया बघितला, सो वी आर ऑलमोस्ट गोइंग टू हॅव अनदर 50 lakh पॉप्युलेशन इन नेक्स्ट 25 years. Then we have to think about the road network, we have to think about the amenity spaces, number of fire stations, because I'm doing everything, but there should be some kind of provisions for the fire department. Number of fire stations has to be increased. So a kind of road network, kind of a firefighting facilities, these all things has to be considered in 2050. Thank you very much.
Thank you very much. Thank you, friends.